Hi, I am Kavitha, Assistant Professor, Department of Mathematics. Today's topic is Introduction to Linear Programming Problem. Linear programming has nothing to do with computer programming. The use of the word programming here means choosing a course of action. Linear programming involves choosing a course of action when the mathematical model of the problem contains only linear functions. Linear programming problem: the maximization or minimization of some quantity is the objective in all linear programming problems. All LP problems have constraints that limit the degree to which the objective can be pursued. A feasible solution satisfies all the problem's constraints. An optimal solution is a feasible solution. The result is in the largest possible objective function value when maximizing or smallest when minimizing. A graphical solution method can be used to solve a linear program with two variables. Problem formulation: both the objective function and the constraints are linear. The problem is referred to as a linear programming problem. Linear functions are functions in which each variable appears in a separate term raised to the first power and is multiplied by a constant which could be 0. Linear constraints are linear functions that are restricted to be less than or equal to or greater than or equal to a constant. Problem formulation. Problem formulation or modeling is the process of translating a verbal statement of a problem into a mathematical statement. Formulating model is an art that can only be mastered with practice and experience. Every LP problem has some unique features, but most problems also have common features. General guidelines for LP model formulation are illustrated on the slides that follow. Guidelines for model formulation. First step is understand the problem thoroughly. Second one, describe the objective, which is minimize or maximize. Third one, describe each constraint. Define the decision variables. Write the objective in terms of the decision variables. Write the constraints in terms of the decision variables. This is the example for a simple maximization problem. Maximize 5x1 plus 7x2 subject to constraints x1 less than or equal to 6, 2x1 plus 3x2 less than or equal to 19, x1 plus x2 less than or equal to 8, x1 greater than or equal to 0 and x2 greater than or equal to 0. Here the objective function is maximum of 5x1, z is equal to 5x1 plus 7x2. This is the objective function and the constraints are x1 less than or equal to 6, 2x1 plus 3x2 less than or equal to 19, x1 plus x2 less than or equal to 8, and non-negativity constraints are x1 greater than or equal to 0 and x2 greater than or equal to 0. In the same type we can write minimize of 5x1 plus 7x2 and subject to constraints are x1 greater than or equal to 6, 2x1 plus 3x2 less than greater than or equal to 19, x1 plus x2 greater than or equal to 9 and x1 greater than or equal to 0 and x2 greater than or equal to 0. This is the another example for linear programming. We can solve this linear programming problem using graphical solution method. This method contains the following steps. Prepare a graph of a feasible solution for each of the constraints. Determine the feasible region that satisfies all the constraints simultaneously. Draw an objective function line. Move parallel objective function lines towards larger objective function values without entirely leaving the feasible region. Any feasible solution on the objective function line with the largest value is an optimal solution. Thank you.